limits and continuity. Now, this one discuss 8.3 continuity. Our aim for today, objective for this class is first explain the continuity of a function at one point, at the point. Second is compute the continuity of a function at one point. We discuss the continuity at only one point. Okay, intuitively, a function is said to be continuous if its graph can be drawn over each interval of its domain with continuous motion of the pen without lifting the pen. Okay, look at the graph. This graph, okay. If you draw the graph, okay, say like this, okay. Then this one consider the graph continuous. And the second graph, okay, look at the second graph and draw the graph. And the graph also consider continuous. Why? Because of it can draw the graph without lifting the pen. Look at this graph. Okay. And check. We draw this one until here and stop. And then continue at this point and continue. Okay. So this is considered discontinuous. Okay, look at this graph. We draw this one and stop and continue and draw the graph. This graph considered discontinuous. Why? Because we need to stop at the point and lift the pen and continue draw the graph. Okay, and this one. Okay. Okay, and then check and stop and continue draw that one. Even though this one is only one point, one hole, we still need to stop here and continue this one. Lift the pen and continue. So this one consider discontinuous. This one also consider discontinuous. Okay. The continuity of a function at point. Definition: a function f(x) is said to be continuous at x is equal to a if and only if this one satisfies this condition. Three conditions. Okay, first, f of a defined. This is very important. First step, check f(a) defined. Second step, limit f(x) exists when x approaches a. Here is also a. A point, a, same point. And the third is number 1 is equal to number 2. Okay, and what to do? To check step 1, substitute x equals a in the function. Substitute, if you get the value, okay. If you get undefined, means that the function is discontinuous. And the second step is check whether limit this function f(x) as approaches a on the left is equal when x approaches a on the right. Okay, if this one equal, means that the limit exists. The third step is check, is it condition 1 is equal condition 2. If equal, means that the function is said to be continuous. Okay. Remarks: domain are the values of x that will make the function defined. If one of the given condition is not satisfied, then f is not continuous at x is equal to a. Okay, just now we have 3 steps. what first step is not satisfied means that we stop and then conclude the function is not continuous. And all functions are continuous on its domain. Okay. Example 1. Determine whether the function fx is continuous at this point. Okay. And given this graph, we need to discuss when x is equal to -2, when x is equal to 0, x is equal to 2, x is equal to 3. -2, 0, 2, and 3. Okay. And first, the first step is when x at this point negative, okay, when x is equal to -2, f of -2 from the graph here at this point. So this the value f of -2 is equal to 1. The second step is limit this function as approaches -2 from left. -2 from left here. So here, this point means that the function is, the value is equal to 1. Stay 1. Okay, stay 1. And find the limit this function when x approaches -2 from right. -2 from right here. And then check, oh, this is no graph. The graph is here. So the value of x is 2. It's equal to 2. So this one is equal to 2. And check, oh, this is not equal to 1. We can conclude that this function is not continuous. But just want to show you. Therefore, okay, or since limit, okay, limit fx as approaches -2, on the left it's not equal. Limit fx as approaches -2 from right. Therefore, limit fx as approaches -2 does not exist. The third step, limit fx as approaches -2 is not equal to f -2. Therefore, f is not continuous at x is equal to -2. Okay, conclusion. Okay, so first substitute the value. Okay, first step substitute the value. Second step, find the limit x approaches -2 from left. Second, and then find the limit as approaches -2 from right. And then equal. Then conclude that limit fx as approaches -2 does not exist. The third is, therefore, fx is not continuous and x is equal to -2. This is the conclusion. Okay. Okay, at point x is equal to 0. When x is equal to 0, okay, first step, f of 0 is equal to, what's the graph? Okay. Right. F of 0 is equal to 5. 5. The second, limit fx is fx. Okay, x approaches 0 from left. Okay, use this one, 0, 0, 0 from left is equal to, so is infinity. Is equal to positive infinity. So since this one not equal, I then conclude, therefore Okay, limit fx does not exist. Okay, limit fx, limit fx. Fx is not continuous at x is equal to 0. Okay, just stop. No need to continue to find limit fx as x approaches 0 from right. No need. Okay. Okay. And okay, then stop. No need to do until this one. No need. No need. Once you get different one and stop, conclude, the limit does not continuous. Oh, this is perfect one. Actually, this is perfect solution. Okay. P at 2. Okay. So here, when x is equal to 2, okay, first substitute, means that here is f of 2 is equal to 2. Okay. Second, find the limit fx. This is fx. We don't know what is fx. Just name fx. X approaches 2 from left. 2 from left. This one. So this one consider. Okay, continue. And limit fx as x approaches 2 from right. From right here. Also 2. Okay. Since this one equal, we can conclude that limit fx as x approaches 2 is equal to 2. Okay, because of equal on the left is equal to on the right. Therefore, when x is equal to 2, when x approaches 2, this limit is equal to 2. Okay, and because of the same value, and then conclude that the third, since limit fx as x approaches 2 is equal to f of 2 is equal to 2, therefore f is continuous at x is equal to 2. Okay, so when you want to show this point continuous, this function continuous at the point, you need to follow all the 3 steps. Okay, conclude, then conclude. Okay, so you need to follow the 3 steps. Okay, when x is equal to 3. Okay, when x is equal to 3, this one is equal to 2. Okay, at this point. Okay, and this point is, okay, set up. Then find the limit. Okay, find the limit. Limit fx as x approaches 2 from left, from right. Yeah, this is 3. Okay, from left, this one is 3. From right also 3. Okay, therefore limit fx as approaches 3 is 3. Is 2. So conclude that limit this one, limit fx as x approaches 3 is equal to 3, not equal f3. Number 1 not equal to number 2. Therefore, f is not continuous at x is equal to 3. Okay. So example 2, determine the point where the function fx given is not continuous. So first thing, you need to find domain. Okay, domain of f. Okay, everything denominator here, real numbers except 0. Okay, so x not equal to 1 or x not equal to negative 2. Then when x is equal to 1 and x is equal to negative 2, fx is undefined. So therefore f is not continuous at x is equal to 1 and x is equal to negative 2y when you substitute f, okay, here. When x is equal to 1, substitute f of 1, 3 over 0. This is infinity, undefined, and stop. This is first step. You don't have to follow the second step and the third step. The first step, substitute, then get undefined and stop. Okay? When x is equal to negative 2, first step, f of negative 2, substitute 3 of negative 3, 0. This is also infinite, undefined. So this is the first step. Don't have to find limit. Okay? When the first step out of 3 steps fail to satisfy, and then consider this function is discontinuous or not continuous at this point and also at this point. Okay? Find domain. When the x is not in the domain, because that one is discontinuous. Consider not continuous. Okay. Example 3. Sketch the graph of the function hence determine the continuity of f at 0 at 2. Okay. Sketch this function and determine this one. Okay. Consider this is 0. So determine the continuity at point 0. This is 2. Consider check whether the continuity at this point 2. Okay. Okay. How to sketch the graph? Transfer to number line. Okay. This is 0. When x less than 0, the function is quadratic. When more or equal 0, this is straight line or linear. So, okay, sketch here. Consider y exists, x exists. Okay, this one 0, origin. Okay, so here you need to sketch the graph y is equal to x plus 1. Sketch graph. Substitute 0, 0 plus 1 is 1. 1. So this is then circle, then circle. When x is equal to 1, y is equal to 2. So the graph is straight line. Okay. Like this. Okay. Or fx. Fx. Okay, settle for the first part. Here on this part, you need to sketch quadratic. Okay, sketch quadratic. Y is equal to x squared plus 2x plus 1 or x plus 1 squared. Okay, the graph is smiling graph like this. Smiling graph. Okay, and this is for quadratic. But we just consider on the left hand side. Here actually that empty circle. When x is equal to 0, substitute 0 plus 1, 1. So here. And the graph is curved. Like this. Okay, this is graph. Okay. Then we're going to discuss what happened when x is equal to 0. Okay. Actually from the graph, it shows that fx is continuous at x is equal to 0 from the graph. Why? Because if you sketch the graph, okay, or trace the graph, you can trace without lifting the pen. Okay, or if you're not sure, just check using the 3 steps. Okay, without sketching, you can check with using the 3 steps first. F0 is equal to 1. The second is find the limit. The third is number 1 is equal to number 2. If it's equal, means that conclude that f is continuous. Okay. This graph. and f is continuous. That's it. Okay. Okay, the second is transfer this piecewise to number line. This is okay, here. Set to real number. So set to the function is 1 over 3x minus 6. 1 over 3x minus 6 when x is equal to 2, y 0. This is y 0. Just a point. Okay, so you want to sketch graph. Okay, this one is considered 0. Okay, drag this one. Okay, y exists, x exists, y origin. So just okay, dotted line. This is 2. Okay, then when x is equal to 2, y 0. So this is the point. Okay, 2, 0 coordinate. Okay, when set to the graph is this one. Okay, and then how to sketch the graph? Okay, let's say just you can find asymptote. Okay, or substitute. Okay, find that one. What happened when limit of 1 over 3x minus 6 as x approaches 3 from x approaches 2 from left. Okay, substitute. This one is equal to 1 over 6 minus 6. 1 over 0, infinity. And check. 2 left means that 1.99 something. This is less than 6. So, should be negative. And check when limit this one 3x minus 6 as x approaches 2 from right. 1 over 6 minus 6. 2 from right 2.001. So 6 plus. This one is consider 0 plus and then positive infinity. So positive infinity, that one is negative infinity. And what happened when x approaches negative infinity or positive infinity? 1 over 3x minus 6. Substitute 1 over infinity 0. Okay, 0. Also negative infinity also 0. So asymptote, this is asymptote, and asymptote. Okay, you can sketch the graph. The graph is like this. This graph. And when x is equal to 0, substitute 0 minus 6, 1 over negative 6. Okay, cut y exists at negative 1 over 6. The graph is this. Okay, so that one is asymptote. X is equal to 2 and y equals 0 is horizontal asymptote. Horizontal asymptote, y is equal to 0. Vertical asymptote when x is equal to 2. Then from the graph, if you sketch the graph, and stop, and you need to leave the pen and continue sketch the graph. So we can conclude that f is not continuous at x is equal to 2. Okay, not continuous. Okay. Example 4. Given. Okay, example 4. Given f continuous means that f satisfy the three conditions. First, second, and third. Now we're going to find k, value constant. So at x is equal to 1. So actually from the piecewise function, we can transfer to number line. 1 here, 1. X more than 1, the function is kx squared minus 2. When x less or equal to 1, the function is 2 minus x. Okay, and this one is left and right. First step, follow the first step. F of 1. Why? Because of we're going to discuss when x is equal to 1. F of 1 means that just a point here, this one. Then circle. This point lies here. 2 minus x. Okay, means that we need to use this function 2 minus x. X is equal to 1. 2 minus 1 is equal to 1. Settle. First step, settle. The second step, okay, you can take on the left or better take on the right. Why? Because of this one already taken. If you take this one, let's say, as a purchase one from left, here from left, okay, this point lies also on the same function. Substitute is equal to 1. There is no use. We're going to find value k. So that's why we should take when x approaches 1 from right. Why? Because of when 1 from right here. Okay, so the point is lies on this line. So we're going to take this function kx squared minus 2. Substitute k 1 squared minus 2 is equal to k minus 2. And given k f continuous, so the third is okay, number 1 is equal to number 2. Step 1 is equal to step 2. So take this one, okay, is equal to this one. Just take that one. Limit of f of 1 is equal to limit fx as approaches 1 from right. f1 is equal to 1. And k from right is equal to k minus 2. Therefore, k is equal to 3. Okay, so now let's say if you want to find this one, say can I take this one on the left is equal to on the right. Okay, this is just to show limit exists. We're going to take the concept continuity. Means that take the first one and is equal to whether on the left or on the right. Okay, so just take the opposite. This one is equal to this. Okay, so k is equal to 3. Okay, for this example, find the value of k for this one. Okay, so this is not equal to k, it's equal to k. Just now, the previous example, more or less. Okay, here, equal or not equal. Given that this function also continuous at x is equal to k. Okay, we're going to find k. Okay, transfer this one to number 9. This is k, not equal to k. The function is x squared minus k squared over x minus k. When x is equal to k, the value is 6. This is k 6, just a point. So first step, f of k. F of k here 6. You cannot substitute into this function. Why? Because of given x not equal to k. K not lies on the line, but k given is equal to 6. Okay. Step 2. Limit x approaches k this function. Okay. Just substitute k. Why? Because of on the left, on the right, the function is equal. The function is equal. Okay, the function equal. Just take when x approaches k. Substitute. When you substitute k squared minus k squared over k minus k, this one is equal to 0 over 0 in determinate form. When in determinate form, you need to factorize. Go to limit, factorize x minus k, x plus k over x minus k. Cancel. Is equal to limit x plus k. Sx approaches k. So now, given h is continuous, okay, it implies that step 1 is equal to step 2. The third, this is the third step. The third step, step 1 equals step 2. So, step 2 here, step 2 equals step 1. Limit k fx, sx approaches k is equal to fa. So this one is equal to substitute k plus k is equal to 2k. 2k is equal to 6. Therefore, k is equal to 3. Settle. Okay. Just follow the 3 steps. Okay. Example 6. Given this function, piecewise function, and find the values of a and b if f is continuous at x equals 3, x equals 5. Okay, so transfer this piecewise to number line. So here is 3, 5. 3, 5. X less or equal 3. And equal included. This function is ax squared plus 2. Ax lies between 3 and 5. Not included. So this function is bx plus 1. And when x more or equal 5, included, fx is equal to 4. Okay, see, I write in different level. Okay, this one. Okay, and now discuss when x is equal to 3. Okay, at this point, when x is equal to 3. Okay. So follow the first step. Actually, given f is continuous all, so we just want to find the value of k, a and b. So at this point, x equals 3. First step, f of 3. First step, f of 3. And step, f of 3 here. Then circle here. Then circle at just 1 point. This then circle lies here and satisfy this equation. So a x squared plus 2. Substitute 3. And then this one is equal to 9 a plus 2. So consider equation 1. The second step, find limit. Limit, and check before you choose limit on the left and also on the right. Okay, the best is we're going to consider x approaches 3 from the different function. If you take from left, you are using the same function as when x is equal to 3. Okay, so we need to take another one, the different one, that is 3 from right. 3 from right, choose this function b x plus 1. This one, 1. Substitute 3b plus 1. Okay, at this point, x equals 3. Follow the third step. The third step is, let's say this is equation 1, equation 2. The third step is equation 1 is equal to equation 2. Or number 1 is number 2. Then 9a plus 2 is equal to 3b plus 1. Yeah? And or simplify, 9a minus 3b is equal to negative 1. Settle for this point. When at this point x is equal to 5. Follow the 3 steps. First step, f of 5. F of 5, the dense circle lies here. Here is 4. So it's equal to 4. Okay. The second step, limit x approaches 5 and choose 5 left or right. If you choose on the right, you take the same 4. So you cannot solve. Okay? So choose the opposite. So choose the 5 from left. Now you can take b x plus 1. Then substitute 5b plus 1. Okay, on this part, this is equation 1, equation 2. The third step here, equation 1, here is equal to equation 2. 1 equals 2. Then 5b plus 1 is equal to 4. 5b is equal to 3. Therefore, b is equal to 3 over 5. Then substitute. Okay. 9a minus 3. 3 over 5 is equal to negative 1. 9a. Okay. 9 over 5 minus 1. And find the value of a. Here is 9a equals 4 over 5. Then a is equal to 4 over 45. Okay, settle for value a and b. Nice. The function g is defined as also piecewise function. Domain, okay, not equal to this one, out of this domain. Determine the value of a if g are continuous and x is equal to 3 and x is equal to negative 3. That domain. Okay. Okay, transfer to number line. Negative 3. X lies between negative 3 included to 3. This function is ax squared minus 18. Okay, this is out. Okay, not equal. So, empty circle to the infinity. The function is x squared minus 9. So, also not equal to negative infinity to negative 3 included. Okay, the function is x squared minus 9, square root. Okay. So now at this point, or at this point, okay, continuous. Let's say if you want to consider when x is equal to 3, okay, here, left or right, okay, we're going to find a. Okay, so first step, f of 3 lies here. Because of the circle, you need to choose this function. A x squared minus 18, 3 to 3, get 9a minus 15. The second step, find limit x approaches 3 from left or from right. So since on the left hand side you choose the same function, so we take on the right hand side. That one is different function. So on the right hand side, the function is x squared minus 9. Substitute 9 minus 9 is equal to 0. Step 3, number 1 equals number 2, number 2 equals number 1. So this one equal. Okay. This one is equal. So 9a minus 18 is equal to 0. 9a equals 18. Therefore, a is equal to 2. Okay, don't have to take negative 3 here because of it. That's fine. A is equal to, with using the x is equal to 3. Okay. Conclusion, continuity of a point at point, definition, function f is said to be continuous at x is equal to a if and only if satisfy the 3 conditions. Okay, f of a defined, limit x approaches a exists, and number 1 equals number 2. That's it. So that's it for lecture chapter limit and continuity.